In this triangle, triangle ABD, we have two smaller triangles. We have triangle ACD and triangle ABC. And the first thing we want to figure out is what is the ratio of the area of triangle ABC to the area of triangle ACD. So let's take these two triangles and draw them separately. We'll take triangle ACD. This is 20. And then let's take triangle ABC. Now from here, notice that the altitude from A is the same for both triangles. So in triangle ACD, the altitude from A looks like this. And for triangle ABC, the altitude goes down here. So we need to extend side BC a little bit. And since both of these altitudes are dropping from point A, they are both equal to each other. So let's denote this altitude by h. H for height. And now, since we have a height and a base for each triangle, we can find the areas for both of these triangles. So let's start with triangle ACD. The area of triangle ACD is going to be a half times the base, which is 20, times the height, which we've called h. And for triangle ABC, the area is going to be a half times the base, which is 30, times the height, which is also h. And when we simplify everything, this becomes 10h, and this becomes 15h. And now we can find the ratio of the area of ABC to the area of ACD. The area of triangle ABC is 15h. The area of triangle ACD is 10h. So the ratio of ABC to ACD ends up being 15h over 10h, which simplifies to 3/2. Now this is very interesting because 3/2 also happens to be the exact same as BC over CD. BC is 30, CD is 20. 30/20 also happens to be 3/2. So is this relationship just a coincidence? The ratio of the area of ABC to the area of ACD is just the same as BC over CD. Well, let's take a look at the next problem. So this time, we need to find the ratio of the area of triangle ABC to the whole triangle ABD. Now once again, notice that both triangles share the same altitude from point A. And once again, let's denote this altitude by h. So that the area of triangle ABC ends up being a half times the base, which is BC, times the height, which is h, and the area of triangle ABD ends up being a half times the base. Now this time, the base is this entire portion, BD, and the height is still the same. And now we see the halves go away and the heights go away. So all we're left with is our bases. BC is 30, BD is this entire portion, 30 plus 20, which ends up being 50. So our ratio ends up being 30 over 50, which simplifies to 3 over 5. Which is BC over BD. So now we see why our previous result wasn't a coincidence as well. If two triangles share an altitude, then when we take their ratios, the halves will cancel and the heights will cancel. So all we're left with is the ratio of their bases. So now let's take what we've learned from our two examples and make a general statement. So from our two previous examples, we can make this general statement. If two triangles share an altitude, then the ratio of their areas is the ratio of the bases to which that altitude is drawn. So here, if we're asked to find the ratio of the area of ABC to the area of ACD, instead of drawing our triangles out like we did last time, we can just use what we know now, because that'll give us the answer much quicker. Both of these triangles share an altitude from point A, so the ratio of their areas is just going to be the ratio of the bases to which this altitude is drawn. So in triangle ABC, this altitude is drawn to side BC, which ends up being 40. And in triangle ACD, this altitude is drawn to side CD, which is 30. So the ratio of the area of ABC to ACD is 4 over 3. And now, once again, both of these triangles, triangle ACD and triangle ABD, both share an altitude from point A. So this ratio is just going to be, very quickly, 30 over BD, which is 30 plus 40, which is 70. And this simplifies to 3 over 7. So this is a very nice property that we just learned about. And you would typically think to use this when you have multiple bases along the same line. So over here, base CD, base BC, and base BD are all along the same line, and all three triangles share the same altitude coming from point A. So all we're really doing is training your eye to see multiple triangles which share the same altitude. Now get ready, because you're going to get a lot of practice using this very useful concept.